Okay, we've reached the last essential question in this short unit. How do I find the missing dimensions of a rectangular prism given the volume? I want you to take a look at workbook page 256. We're going to do a couple word problems together. Number 24 says that a ring box in the shape of a rectangular prism has a volume of 25 cubic centimeters. So we're giving you the volume. And we also know that it's 2.5 centimeters tall. What is the area of the base, and notice we have the capital B here, of the ring box? So here's what we're going to do. Let's think about the formulas that we have for finding the volume of a rectangular prism. We know that we can do volume equals length times width times height, or we can do volume equals the area of the base times the height. In this case, since we know the height and we know the volume and all that's missing is the area of the base, I'm probably going to use this formula here. What I'm going to do is I'm going to plug in the values that I do know. I know the volume is 25, so instead of V, I'm going to put 25 there. I don't know the area of the base, so I'm going to leave the capital B there. And let's see, I'm multiplying the height, and the height was given, that was 2.5 centimeters. So now I have an equation that I have to solve, which we did in Unit 5. This is a multiplication equation. I can solve for B, the capital B, by dividing, the inverse operation of multiplication. In this case, I have to do 25 divided by 2.5. So let's do this. 25 over 1. And 2.5 is going to become 5 over 2 when I turn it into an improper fraction. So I have 25 over 1 times the reciprocal of 2/5. Don't forget, with division, we're actually multiplying the reciprocal. And then we can actually, do the multiplication. Let's see, 25 times 2 is 50, 1 times 5 is 5, and 50 divided by 5 is going to give me 10. That means that the area of the base is 10 square centimeters. Remember, we were looking for the area, so area is squared. I'm going to use the little exponent 2 to represent area. So that's number 24. Let's take a look at number 25 now. I'm going to erase my work so I have some space here. And maybe we'll do a different color. A jewelry box, so here we have another box, this time a jewelry box, I guess it could be a ring box, in the shape of a rectangular prism, has a volume of 90 inches cubed, or cubic inches, and a height of 2.5 inches. What are the possible dimensions for the length and width of the base? So I might go back and use that formula, volume equals the area of the base times the height. So let's see, our volume is 90. The area of the base we don't know. The height we know is 2.5. So I'm wondering if this is the same, well, I guess it's a different jewelry box, but it happens to have the same height. So let's see. I can solve this multiplication equation by using division. I have to do 90 divided by 2.5, which of course 2.5 is the same as 5 over 2. So 90 over 1 times the reciprocal of now 5 over 2, which becomes 2/5. And then I can actually do the multiplication and the division. 90 times 2 is 180. 1 times 5 is 5. And if I simplify 180 and 180 fifths, or 180 divided by 5, I'm going to get 36. So that's telling me the area of the base is 36 square inches. However, I'm not finished yet. That's just part of my answer. It says, what are the possible dimensions for the length and width of the base? Meaning, what could the length and the width be? There's a couple possibilities. You know, to find the area of the base, we have to do length times width. So we have to think, okay, what times what could give us the area of 36 square inches? Let's see. I could make 36 by doing a length of 1 inch and a width of 36 inches, because 1 times 36 would give me 36. I could also have a length of maybe 2 inches and a width of 18, because 2 times 18 gives me 36. Let's see, what other possibilities could I come up with here? Give some more space. Maybe the length is 3 inches, and the width could be 12 inches, because 3 times 12 gives me 36. Or maybe the length is 4 inches and the width is 9 inches, because 4 times 9 gives me 36. All we're doing is we're coming up with all the possible factors of 36. Maybe the length is 6 and the width is 6, because 6 times 6 gives you 36. So there's a lot of possible dimensions for the length and width, a lot of different ways that you can make 36 square inches. Now we have one more to do, number 26. A storage tank in the shape of a rectangular prism has a volume of 35 cubic meters and a height of 2.5 meters. The length of the base of the prism is 3.5 meters. What is the width of the base of the storage tank? So this time, they're giving us the volume, they're giving us the height, they're also giving us the length. All that's missing is the width. So if you remember, there were a couple different formulas that we could use here. We could use volume equals length times width times height, or we could use volume equals the area of the base times the height. In this case, for number 26, I might use this formula because I've been given the length and the height. All I need is the width. So let's see. The volume is 35. I'm going to plug 35 in where V was. The length is 3.5, so I'll put 3.5 for the length. The width is missing, so I'll leave a W there for width. And let's see, the height is 2.5. So all I did was plug in the values that I have. Now this equation I can actually simplify a little bit before I start to solve it. I can take the 3.5 and the 2.5, because it's all multiplication and I can do multiplication in any order. I'm going to probably get that multiplication done. 3.5 or 3.5 times 2.5 or 2.5 is going to give me 8 and 75 hundredths. So now my new equation looks like this. 35 equals, I still am missing my width, times 8 and 75 hundredths. So now I have, again, this multiplication equation. If I want to solve this multiplication equation, I'm going to do the inverse operation, which is division. So I have to do 35 divided by 8 and 75 hundredths. And when I do 35 divided by 8 and 75 hundredths, I'm going to get 4. The width must be 4 meters. Now this answer, I don't need squared, I don't need cubed, I'm just looking for the width, one dimension. So I don't need any exponents. Unless you want to put the 1 in there, you can if you want to. So, a couple short takeaways. When you're looking for the missing dimensions, assuming you're given the volume, plug the known values into one of the equations. So anything that you know, put it back into one of those equations, whichever equation makes the most sense. And then simplify the equation if possible. So that's typically if you're working with this equation here, the volume equals length times width times height. If you're given, 2 of those 3 dimensions, it probably makes sense to simplify if you can. And then last, solve the equation.